Hello, dear students. You are welcome to session 6 of core mathematics for SHS. So, in this session, we'll be looking at plane geometry 1. Plane geometry 1. Alright, so let's quickly look at the session outline. So, at the end of this session, you should be able to identify the various types of angles, calculate the angles at a point, identify and apply the angle properties of parallel lines, understand and apply angle properties of triangles, understand and apply angle properties of quadrilaterals, and calculate the sum of interior angles and exterior angles of a polygon. Alright, so these are the areas that we'll be looking at in this lesson. Alright, so without much ado, shall we kickstart? Okay, so what is an angle? You see, an angle is formed when at least two lines meet or intersect. So whenever two straight lines come together, the point at which they meet or at which they cross, we call that point an angle, or we say an angle is created at that point of meeting together. You hear me? So when you take this example, this illustration, see we have one straight line here meeting another straight line beneath here. So the point where these two lines meet, an angle is created at that particular point, and that is what we refer to as an angle, right? So angles are basically measured in degrees, right? So we have 20 degrees, 30 degrees, 40 degrees, 80 degrees, and so on and so forth, right? So that is the basic understanding of an angle. So let's look at the various types of angles. So we have a couple of them. So let's start with the acute angle. So what is an acute angle? An acute angle is an angle that is less than 90 degrees. That is, it is within the range of 0 degrees and 90 degrees, right? So any angle that is above 0 degrees but less than 90 degrees is an acute angle. So an example is 30 degrees, 60 degrees, 75 degrees, 80 degrees, 20 degrees. So far as it is less than 90 degrees, we say it is an acute angle. So this is a graphical illustration of an acute angle. Alright, let's proceed. Okay, we also have the right angle, right? So a right angle is an angle that is exactly at 90 degrees. Right, it is exactly at 90 degrees, right? And usually we use this symbol to represent a right angle. It looks like a box, okay, a box. I think most teachers, especially in the primary school, they refer to it as a chair. Right? So they will say that when you see a chair within the two lines, or at the corner where the two lines intersect, it means it is at 90 degrees. Yeah, so that is how you would easily identify that an angle is at 90 degrees, right? So when we talk of right angle, a particular kind of angles come in play, right? And that is what we refer to as the complementary angles, right? And complementary angles are two angles that sum up to 90 degrees, right? So here, for instance, we have this right angle being divided into two, right? So this portion of the angle is A and this portion is B. So we say that A plus B obviously sum up to 90 degrees, right? In that sense, we say that angle A and angle B are complementary angles, and the reason is that they add up to 90 degrees. So simply, two angles that add up to 90 degrees are known as complementary angles. Okay, so let's move on to the next type of angles. So we have the obtuse angle. So this is an angle that is greater than 90 degrees but less than 180 degrees, right? So example is 100 degrees, 120 degrees, 150 degrees, and any other angle that is less than 180 degrees but greater than 90 degrees, right? So this is a graphical illustration of an obtuse angle, right? Okay, let's proceed. Alright, let's look at the reflex angle. So there's an angle that is greater than 180 degrees but less than 360 degrees, right? So that is a reflex angle. So we have examples such as 190 degrees, 230 degrees, and 300 degrees, right? So that is a basic meaning of a reflex angle: greater than 180 degrees but less than 360 degrees, right? So you just have to keep the parameters in mind, right? When you talk of acute, you know that it is greater than 0 but less than 90 degrees. When you talk of right angle, exactly 90 degrees. When you talk of obtuse, greater than 90 degrees but less than 180 degrees. And when you talk of reflex, greater than 180 degrees but less than 360 degrees, right? So just keep these parameters in mind. Alright, okay, let's proceed. Okay, so we have special types of angles, right? So whenever you have a straight line, the angle that is formed on that straight line is equivalent to 180 degrees, right? So as you can see, you have a straight line here, and the angle that is formed on this straight line is the 180 degrees. And whenever two angles sum up to 180 degrees, we call those two angles supplementary angles, right? So if you have a straight line and then you divide that straight line into two, obviously two angles will be created, right? So those two angles that is created on that straight line, we call them supplementary angles because they add up to 180 degrees, right? Okay, so here our x and our y are supplementary angles because x plus y is equal to 180 degrees. Okay, then we move on to angles at a point, right? So whenever you have a point, or let me say a circle, the angle that is formed around that point gives us a total of 360 degrees, right? So the sum of angles in a circle or around a point, the reason why it is the same as around a point and a circle is obviously if you want to draw a circle you need a point, a center, right? So the angle that is created around a point or in a circle is known as, okay, we refer to it as a revolution, right? A revolution. But then the value of the sum of all angles around that point gives us 360 degrees. So here for instance we say A plus B plus C plus D plus A is equal to 360 degrees, right? Because as you can see, all these angles have been created around this central point here, right? So when you add all the angles around this particular point, the total must be equal to 360 degrees. Okay, let's proceed. Okay, let's look at some properties of angles, right? So we have what we call the vertically opposite angles, right? And these are equal angles, right? So let's look at the illustration here. So whenever two lines cross each other, you realize that one angle will be formed at the top, another will be formed at the bottom or beneath it, another will be formed at the left, and another will be formed at the right. Now when we talk of vertically opposite angles, what we are saying is that the angle that is created at the top part is equal to the angle that is created at the down part. Similarly, the angle that is created at the left side is equal to the angle that is created at the right side, right? So A and C are vertically opposite angles, and D and B are also vertically opposite angles, meaning that A must be equal to C and D must be equal to B, right? So that is what we refer to as vertically opposite angles. So it looks like an X, right? So whenever you have two lines crossing each other like an X, the angle formed at the top is equal to the angle formed at the down. The angle formed at the left is equal to the angle formed at the right. I believe it's simple. So let's take a look at this particular example. So if you are to find the values of X, Y, and Z in this particular question, based on your knowledge on vertically opposite angles, you would know that the angle formed at this side, at the left side here, is equal to the angle formed at the right side here. So if you want to find the value of X, it's simply going to be X minus 50, because that is the angle at the left side here. So X minus 50 must be equal to 30 degrees, the angle at the right side. Right, so when you solve for X, you get your X to be equal to what? 80 degrees. As simple as that. Now also you would know that Y must be equal to Z minus what? 10 degrees. Right, so let's first find the value of Y. Right, let's first find the value of Y so we can apply our knowledge on angles on a straight line. Right, so as you can see, Y and 30 degrees forms a straight line. They are supplementary angles, right? So we can say that Y plus 30 must be equal to 180 degrees. So obviously Y is equal to 180 minus 30, and therefore Y is equal to 150 degrees. So that is the value of Y. Now that we know the value of our Y, we can equate to Z minus 10, right, to find the value of Z. Right. So we can say that Y is equal to what? Z minus 10. But then we know that Y is 150. Therefore, Z minus 10 is equal to 150 degrees. Right. So Z is equal to 150 plus 10 degrees, and that gives us 160 degrees for our Z. Right. So that is how you apply your knowledge on vertically opposite angles as well as angles on a straight line. Okay, let's proceed. Okay, let's look at angle properties of parallel lines. So when we talk of parallel lines, there are two lines that do not meet, right? So the distance in between the lines are equal at any given point, right? So when I measure the distance between this line and this line at this particular point, it will be the same as the distance between the two lines at this particular point. So at any point on the two lines, the distance between them is the same throughout, right? So that is what we refer to as parallel lines. Now we also have what we call a transversal. So whenever you have two or more parallel lines and another line is drawn across it or across them, we call that line a transversal, right? So as you can see, this orange line here is our transversal, right? So whenever you have parallel lines and a transversal, you have special types of angles that are created, or there are some properties of the angles that we need to take note of, right? So you realize that when this transversal crosses the two parallel lines, it forms a set of angles, right? So with the first line up here, it would form 4 sets of angles, and with the line beneath here too, it would form another 4 sets of angles, right? So let's say that the angles formed at this section is the upper section, right? So it means that A, B, C, and D are the angles at the upper section of this transversal. Similarly, E, F, G, H are the angles formed at the lower section of this transversal and parallel line, right? So take note of this. We are going to look at some types of angles that are formed when parallel lines and transversal meet, or when we have parallel lines and then a transversal drawn across, right? So let's look at some of the angles. So we have what we call the corresponding angles. Corresponding angles. Now these are angles that are formed at the same position. Right. So when you take the angle formed at the upper section and you compare the position of the angle at the upper section to the angle at the lower section, it is the same position. Right. So for instance, now let's look at the x here. Now this x, if you want to give a position for this x, now this x can be said to be at the top right corner of this particular section, right? The top right. Now when you come to the lower section down here too, the y is also at the top right at the lower section here. So because the x and the y occupy the same position, we say they are corresponding angles, right? So it means that top right upper must be equal to top right lower, down left upper must be equal to down left lower. Right, so let's try to identify the corresponding angles here. So we are going to take each of the angles up here and then we will find their corresponding angles down here. So let's start with A. Now let's first identify the position of A. So we can say A is at the top left corner at the upper section. So it means to get the corresponding angle for A, we need the angle that is at the top left position at the lower section here. Right, so which of the four angles here occupy the top left position down here? It is obviously E. Right, so it means that angle A and angle E are corresponding angles. So when you take B as well, B occupies the top right position up here. So to find its corresponding angle down here, we need an angle that occupies the top right position, and that is angle F. C occupies the top left position up here. So when we come down here, we need the angle that occupies the top left position, and that is G. So C and G form corresponding angles. Finally, D occupies the down right position, and so its corresponding angle down here is obviously H, since it's also at the down right position at the lower section here. Right, so that is what we refer to as corresponding angles. Angles that occupy the same position, right? Be it left or right or top or down, right? Okay, let's move on. Okay, we have the alternate angles. Now these are angles that are formed at odd positions or different or contrasting positions, right? Both in terms of left or right as well as top or down, right? So let's take a look at this example here. So let's take angle A. Now let's identify the position of angle A at the upper section here. And clearly angle A occupies the down left position up here. So we have down and then we have left. So if you want to find its alternate angle down here, you have to find the opposite of down and the opposite of what? Of left. Right, so what's the opposite of down? Opposite of down is what? Is top. And what's the opposite of left? It is right. So the alternate angle of A must be the angle that is at the top right corner at the lower section down here, and that is B. So B obviously is at the top right. So alternate angles occupy different positions, right? Contrasting positions. So whereas A is at the top left, at the down left, B is at the top right. Alright, so that is what we refer to as alternating angles. So let's come back once again and identify our alternating angles here. So when we pick A, now what is the position of A? A is top left. So if I want its alternate angle down here, it has to be what? Down right, and that is H. I believe you get me. So angle A and angle H are alternating angles. When we come to B, B occupies top right. If I want its alternating angle, it has to be what? Down left. So top right, its alternating must be down left. So down left, that is J here. When I come to C, C is what? Down left. Its alternating must be top right, and that is F. So angle C and angle F are what? Alternating angles. Finally, D occupies down right. Its alternating will be what? Top left, and that is angle E. Right, so you just find the opposite of what? Of the positions. Right. Okay, let's proceed. Okay, we also have what we call the co-interior angles. Co-interior angles. So these are angles that are formed within the parallel lines. Right, so they are inside. Interior means inside, right? Within. So when we talk of the interior of a car, we are referring to the inner part of the car, right? So angles formed within parallel lines are co-interior. Co means that they are partners, right? Because they are all inside. So let's take a look at this illustration. So we see angle C and angle D are co-interior angles, right? And one special characteristic of co-interior angles is that they are supplementary angles, meaning that they add up to 180 degrees. So it means C plus D must be equal to what? 180 degrees. Right, so let's come back once again and identify our co-interior angles here. So clearly angle D and angle F are co-interior angles, and also angle C and angle E are co-interior angles. Right. Okay, let's proceed. Okay, let's look at some applications, right, based on our knowledge on angle properties of parallel lines. Let's look at how we can apply it in a practical question. Right, so we are going to apply our knowledge on corresponding angles, alternating angles, and co-interior angles, right, to solve this particular question. Right, so we have to find the value of x in the diagram below. So there's our diagram. So we basically we have two parallel lines. So line GE, right, and line AC are the two parallel lines, and then we have something like an incomplete triangle within, right? Yeah. And then we have some angles labeled at various corners of the transversal and these two lines. So angle JFD is 135 degrees, angle FDB is X, and angle CBD is 42 degrees. So when you are reading angles, we read angles based on 3 points, right? Based on 3 points, and then where the angle is located must appear in the middle. So when you are writing the angle, you have to take note of where that particular angle is, and the letter or the point that corresponds to where the angle is will be in the middle. So if I want to name the angle here, the 42 degrees angle here, now what 3 points are coming together to give me this angle? It is point D, point B, and point C. Right, so I can name this angle as DBC or CBD. The bottom line is that the B where the angle is formed must be in the center, in the middle. Right, so that is that about reading angles. Right, so whenever you have a question as this, now what you can do is that draw another parallel line in between the point here, or in the middle section here. Right, so draw a parallel line, right, so that we can apply our knowledge on, corresponding angles, alternating angles, and co-interior angles. Right, yeah, because what you realize is that this is not a straight transversal. Right, so this one looks more of like two different transversals. Right, two different transversals. So in order that we get just one transversal, let's draw a parallel line in between this point here, right? So in the middle section here, right? So the new line here was line MN, right? Line MN, and then it meets this point here at D, right? So you can use any value, or let me say any labeling, right? So you can decide to use XY, PQ, whatever you would like to use, right? So that is what you can do. So now we can deal with these two as two separate parallel lines with a transversal. So it means that our FD will look like a transversal to us. And then when we come to line MN and AC, there will be another set of parallel lines with the transversal BD, right? So it means you are going to treat them as separate parallel lines and separate transversals. I believe you get it. Yeah. So let's focus on these two parallel lines, the first two, that is GE and MN, and let's apply the various properties of the angles that we just looked at. So now clearly you can tell that angle GFD, so GFD, so that is angle 135 degrees, right? This angle here, plus FDM, so this angle here, right? Now they are co-interior angles, right? Because we said co-interior angles are angles that are formed within the two parallel lines. So as you can see, this angle here and this angle here form co-interior angles, and we said co-interior angles are supplementary angles, that is, they add up to 180 degrees. So if I want to find the angle at this point, at this particular point, that is angle FDM, is simply going to be 180 minus the 135, right? So it means that my FDM is equal to 180 minus 135, and that is 45 degrees, right? So take note of that. So FDM is 45 degrees. Now let's move on. Let's come to the second parallel lines, or let me say the last two parallel lines, and let's look at how we can apply the various properties. Now we say angle BDM, so let's see, BDM, right? So this angle here, BDM, so it means this angle here is equal to angle DBC, so DBC, that is the angle here, the 42 degree angle here. And the reason is that they are what? Alternating angles, right? And what did we say about alternating angles? They are equal, right? So okay, why is BDM and DBC alternating angles? Clearly this angle is at the down left of this transversal and parallel line, and this one is at the top right, right? So that is why they are alternating angles, right? Usually alternating, one way to easily identify alternating angles is that they look more of like a Z shape, right? So whenever you have a Z, the angle for that is formed at the two corners, right? They are alternating angles, right? They are classic picture of an alternating angles, right? So angle FDM, sorry, it's not FDM, BDM rather, angle BDM, this angle, and DBC, the 42 degree angle, are alternating angles, and they are equal. So it means that angle BDM is also equal to 42 degrees. So that's it, angle BDM is equal to DBC is equal to 42 degrees, because they are alternating angles, and alternating angles are equal, right? So here is 42 degrees. Now we're told to find the value of x, right? But if you would realize something here, this x has been divided into two separate angles, and that is the angle FDM, right? FDM, that's this portion here, and BDM, this portion here, right? And we've successfully found the values of FDM, that was 45 degrees, as well as BDM, that was what, 42 degrees. So how do we find the value of x? Well, x has been divided into these two separate angles, so that when we put the two angles together, we would arrive at our x. So our x is simply equal to angle FDM, so FDM, this one, plus BDM, this one, right? So FDM is 45 degrees and BDM is 42 degrees. So angle X is equal to 87 degrees. Right, so that is how you can solve this question. So whenever you see something like this, just draw another parallel line in the middle section here, and then treat them as different parallel lines and not transversals. And then you apply your knowledge on corresponding, alternating, and co-interior angles to solve it. Right? Alright, so that is that for the angle properties of parallel lines and transversal